John Dalton was an English meteorologist who was born in England in 1766. Dalton is credited as one of the first people to propose the idea of the atom after observing and applying chemistry ideas to the atmosphere around him. In 1803, he came up with the idea of an atomic theory as a result of his research into gases. The atomic theory: 1. Atoms are tiny indivisible particles of elements. 2. All elements are composed of atoms. 3. Atoms of the same elements are identical. 4. Atoms combine in mixed ratios to form compounds. Dalton discovered that certain gases could only be combined in certain proportions, which led him to believe that elements combine together at a smaller atomic level in fixed ratios. This revolutionary discovery led to his atomic theory. At the time, his theory was considered true for all reactions and atoms. The billiard ball model. When Dalton proposed his idea, it was thought that the atom was a simple indivisible sphere. At the time, he was unable to identify the smaller characteristics of the atom, the protons, neutrons, and electrons. Thomson discovered that the atom was divisible. Rutherford was a New Zealand-born physicist who is one of the most revolutionary scientists of all time, sometimes referred to as the father of nuclear physics. Rutherford is known for his discovery of alpha and beta rays as well as identifying what an alpha particle is, although he was a mere contributor to the wealth of science. He is the best known for his model of the atom and is responsible for the discovery of the nucleus. Rutherford was able to discover the nucleus using the gold foil experiment. In this experiment, he solved alpha particles at an extremely thin piece of gold that was surrounded by a detecting screen. Wherever the alpha particle hit the screen, it would flash. He expected that all the alpha particles would end up directly behind the gold foil, but the results showed differently. Rutherford proposed that the atom consisted of a extremely dense positive medium called the nucleus, which was surrounded by negative electrons that circled the nucleus in orbital. The problem with this model is that it doesn't follow the rules of circular motion and electromagnetic radiation. The orbiting electron should accelerate because it is experiencing a centripetal force, and according to Maxwell's electromagnetic theory, any accelerating charge should emit electromagnetic radiation. Born in Denmark, Bohr studied under Thomson and Rutherford and eventually furthered the understanding of the planetary model. Bohr extended and corrected the problems that arose with the planetary model and further defined how electrons move in their orbits and sustained at energy levels. He also stated that the energy levels are dependent on the orbit radius and that electrons move in fixed orbits. When the electrons use energy to jump from one energy level to the next, radiation is emitted. Bohr discovered that electrons travel in separate orbits around the nucleus and that the number of electrons in the outer orbit determines the different properties of an element. This concept is known as an electron shell. He was able to determine this by looking at the emission spectrum of a hydrogen atom. Bohr's model of the atom consisted of electrons in specific energy levels as well as the nucleus, which consisted of protons and neutrons.